Hello space fans, welcome to another edition of Space Fan News. This week we're going to take an in-depth look at the recent announcement that came from the Kepler Space Telescope mission that more than doubled the number of known confirmed exoplanets out there. So earlier this month, if you've been following anything at all with the Kepler Space Telescope mission, then you would have noticed on May 10th that there was a sudden increase, in fact a doubling of the number of confirmed exoplanets found by astronomers using data from the Kepler Space Telescope. And well, over the course of the years of Space Fan News, I've tried to be really good about keeping you up to date on these discoveries as they are unfolding from this mission. And usually, as we watch the number of confirmed exoplanets climb, we usually see it going by 1 or 2 or 3 or sometimes 5 at a time, because each of these candidates have to be confirmed, and the process of confirming them takes a while. So it's a fair question to ask, what happened on May 10th when NASA basically doubled the number of not candidate planets, but confirmed planets? So what's different? What happened this time? And that's what the subject of this episode's about. So in order to understand why there was a sudden jump in the number of confirmed exoplanets, you have to understand the difference between a candidate exoplanet and a confirmed exoplanet. Now remember, and we've talked about this many times over the course of SFN, plus I've posted a lot of videos on this channel about this, but the Kepler Space Telescope was launched in 2009 and it was designed to find Earth-like planets. And it did that, or it was going to do that, by staring at one spot in the sky, the constellation of Cygnus, and look at almost 160,000 stars and measure very accurately their brightness as it changed when potential planets passed in front of it and the host star. So for 4 years, Kepler looked at these stars and measured the brightness. It would take an image, download it, take an image, download it, take an image and download it. And over the 4 years, it built up a time series of basically a movie of this one spot in the sky, 160,000 stars. And every time Kepler found a tiny dip in brightness, it would flag it and say, aha, something passed in front of this host star. And it marked it as a candidate. Now, it still needed to be confirmed, though, because it might not necessarily have been an exoplanet that caused the dip in brightness. It could have been a brown dwarf, could have been a red dwarf star, or could have been a comet. It could have been something else besides an exoplanet. So it needed to be confirmed. And that process of confirming whether that dip in brightness was, in fact, an exoplanet or not takes time. Astronomers use ground-based telescopes for follow-up observations because space telescopes like the Hubble are very, very busy, and so ground-based telescopes have to follow up and confirm it, and that takes time. All Kepler was doing was just taking these snapshots of this one area over and over again for over 4 years. So it's interesting that on May 10th, the announcement was made that 1,284 new planets have been added to the confirmed side of the Kepler catalog. So as I was looking into this story, I became very curious about how they could confirm so many exoplanets all at one time. And it turns out the difference between what's going on with this announcement and previous confirmations is that a team from Princeton, astronomers using Kepler data, have developed a statistical automated method that goes through all of the Kepler data, and specifically the June 2015 catalog, which is the most recent catalog of Kepler data after it's been analyzed. And they looked at all of the potential signals generated by the Kepler data. Now, a signal is defined as simply a dip in brightness. If there's a dip in brightness, boom, that's a candidate, it's a signal, let's take a closer look. And so then they apply 2 simulations to it to assign the probability that this is actually a planet. The first one that they look at is even though dips in brightness all look kind of the same on a big level, there's actually small, tiny differences between the light curves depending on what caused the dip in the first place. So an exoplanet makes a very definite shape of a light curve, while something else like a red dwarf or a brown dwarf would make a slightly different light curve, followed by maybe even a comet would do something even more different. So they ran 2 simulations on every signal. The first one said, how does this compare with the exoplanets that we know of and the kind of light curves they make? And what does this light curve look like compared to the imposters, the stars, the red dwarfs, things like that? And they compared the two and they assigned a probability to every one. And only the candidates that reached a 99% level of certainty in the statistical simulation were given confirmed status. So that's how they did it. And this is a really powerful technique because now we don't have to sit there and do these onesies, twosies all the time. They can look at the entire Kepler data set and get big swaths of the data done at one time. So that's how they were able to get 1,284 new confirmed exoplanets out of the Kepler data all at one time. And that is what I call working smart and not hard. So over the 4 years that Kepler was looking at this spot in the sky and the constellation Cygnus, they had come up with 4,302 potential planets. These were candidates. And before the announcement on May 10th, there was about 1,200 confirmed exoplanets. So this recent announcement more than doubled the current confirmed count. So of the 1,284 planets that were announced on May 10th, 550 of them are small, possibly rocky planets, with 9 of those planets being within the so-called habitable zone. That's that thing where, you know, the planet is far enough away from the star where liquid water might be present. So it's a very important spot to look for potential life. So now where do we stand with exoplanets? Well, counting all sources of exoplanet discoveries in the 5,000 or so exoplanet candidates that are out there, including Kepler, then 3,200 now of those 5,000 have been verified. And 2,325 of these exoplanets were discovered by Kepler. So exoplanet science is really going strong. Okay, so now for a little bit of commentary. I want to start by apologizing for not posting for the last 2 weeks, but if you had any idea what my life was like lately, I think you might understand. But I'm sorry about that, the delay, but I'm back into posting now. And I hope you kind of like this new format. I'm jumbling up a little bit here, just to kind of make things interesting. I wanted to kind of delve into the stories themselves a little bit more instead of trying to do so much all the time. I also want to thank you for your kind comments on the last SFN. You really helped me crystallize what I'm doing here, because I have to tell you, doing science outreach and astronomy outreach on the internet can be a little bit of a echo chamber sometimes. You get to see all of the same people saying all of the same things, and I was beginning to wonder I was just another voice in the crowd. And so it was nice to hear you guys tell me that that this is all new stuff to you, that you are getting useful information from what I'm providing. And so I'll continue to do it, and I want to thank you very much for letting me know, because like I said, this is kind of an echo chamber sometimes, and I just want to make sure I'm giving you good content that you're not getting anywhere else that is actually useful to you. So I just wanted to thank you for that really great feedback, as it really helps me to do a better job with these videos. Well, that's it for this week, space fans. I want to thank you all very much for watching, and thank you for your kind comments. Please keep them coming. I want to thank all of my Patreon supporters for supporting SFN. If you'd like to support, if you find this useful, please feel free to support in the link down below in the description box. And also, don't forget to like the Space Fan News Facebook channel, because I'll be posting new bits and smaller stories there periodically throughout the week. Also, every week on the Deep Astronomy Facebook page, I will be doing a Q&A live at 3 p.m. Eastern on Wednesdays, starting this coming Wednesday. So I hope you like that as well, and I will see you then. So thanks again, and as always, keep looking. Hello, Space Telescope. Hello, Space Telescopes. Welcome to another edition. What am I doing? I got through it. I can't believe it.